Welcome to Tenor Tech, where I solve the problems you didn't even know you had.
You begin by locking down the core design decisions, orientation, draft, and where the part will split. Start with a watertight solid body in Solidworks so downstream operations don't fail. Once done, add 1 degrees 3 degrees draft where needed and remove fillets under a threshold to ease mold making. Make sure to sketch the parting line and mark the proposed sprue and runner location now. These early choices reduce iterations when you convert to tooling features. You now convert the design into tooling. Use the split tool to cut the model along the parting surface so you get separate core and cavity bodies. Then offset faces to account for shrinkage and machining allowance, for example 1-3% or a fixed 0. 5 mm, so cast parts match final specs. Once done, add draft and radiused edges to the mold halves to assist release, and model alignment pins and locating features. These maintain repeatability and simplify assembly of the tooling. You finish by validating and exporting. Run a mold flow simulation or perform manual checks for undercuts, thin walls, and venting. If you see air traps or cold spots, move gates, add vents, or increase wall thickness in problem zones, these changes improve fill and reduce porosity. Then clean up part names, add identifiers to faces, and export the mold halves as step or parasolid for machining. If things go wrong, inspect the simulation hotspots and iterate on gates or draft angles.
Thanks for watching. Subscribe to keep your life in tune.